As we get into these, I want you to focus on concept. You've actually got all the mathematical knowledge to do these. They just look a little different than you're used to. So, up top where it says example, I want you to check this out, okay? It looks like, dang, I can't do anything with this, right? Kind of looks like that. But when you see that 20, I hope you can see that we can simplify that square root of 20. Everybody seeing that?
Yes.
So check out. What might be a factor of 20 that I could use? Yeah, 4 and 5, right? This is the example at the top in your notes. So 4 says, cash me outside, baby. Negative 8. Nope. It's negative 4. Square roots of 5 minus 2 square roots of 5. Right? That 4 comes out as a 2 times that negative 2 is negative 4. Now, if I have negative 4 square roots of 5 and negative 2 square roots of 5, that means I have negative 6 square roots of 5. Kind of works like a variable a little bit, right? It always works out if you have the same square root. If you have the same radical. Okay. So just looking at number 1 on your PDF notes, 3 square roots of 6 minus 2 square roots of 6. That's 1 square root of 6. Just boom, done. Right? Just straight up square root of 6. Let's check out number 3. So as you see number 3, what you guys think?
We can do 63, we can do 9, 7.
Yeah, 63 has factors of 7 and 9, and that's cool. Because 9 is a perfect square, right?
Yeah.
So I'm going to rewrite it as 2 square roots of 9 times 7. What does 9 say? Cash me outside, baby. As a 6 square roots of 7. So if I have 10 square roots of 7 and I have 6 square roots of 7, I have 16 square roots of 7. Cool. I want you to try number 6 on your PDF. On your own, please.
I don't understand.
Yet. So, get it wrong then, man. You know what I say about mistakes? Don't make them, otherwise everybody hates you. No, I mean, mistakes are good. It depends what you do with it. I was being sarcastic with that first one. I love mistakes. Let's start breaking this up. How did you break up 28?
I got it to 7, 4.
Okay, I like it. How'd you break up 112? Well, that one's harder, so let me show you what I like to do. I divide it by 2, and I get 56. I divide that by 2, I get 28. I divide that by 2, I get 14. I divide that by 2, I get 27. Now, see how there's these double 2's? That means anything that's doubled, I can take the square root of. So 2 factors of 4 there is a factor of 16. So I know that that's a 16 times 7.
What?
Yeah, that's what we learned yesterday.
Yeah, I'm just showing you. I like to decompose my number to see how it's made up. It makes it easier for me to find that perfect square, other than just like smashing a calculator, you know.
I just don't get the 2 and 2 and 2 and 2.
So I split it up. 2 times 56, and then I split my 56. 2 times 28. So I just broke it down, and then kept track of how I broke it down. So see how there's 2 factors of 2 in there? That's a factor of 4.
You can do it by 4.
See how there's 2 factors of 2? That's a factor of 4.
You can just do it by 4 too and get to 28.
So I knew if there's 2 factors of 4, there's a factor of 16. And then all that would be left is the 7. So I like to decompose it by doing that factorization right there.
Why did you have
I didn't have to. It's just a strategy.
But why not just stop at the 2 2's and then
28 times 4?
Because 28 can be divided by 4.
Because 28 has a factor of 4 in it still.
Well, why did you have to Why did
What-
you have to split up 28 since you could get 112 to be 28?
You could, but then you're going to get an answer that you'll still have to simplify. Because, like, what answer did you get?
4 square root of 28.
Yeah, but a square root of 28 is not simplest because it still has a factor of 4 in it, right?
Oh.
Yeah, so what I would do it like this.
Oh yeah.
You could use that, but then you still have to simplify. I'm gonna get this stuff out. Negative 8 square roots of 7 plus 16 square roots of 7. What's the total square roots of 7 I got then? 8 square roots of 7. So let's say you did that. Let's say on this one, oh, you got them both in 28. You got to still get that 4 out of that 28, right, Sam? Okay, cool. Good. I feel pretty good about the rest of that first page there. Let's turn it to the next page in your PDF. We're going to step our game up a little bit. I say we go right to number 13, man. Let's rock 3 things. We can add 3 things. It's like only adding 1 more thing than adding 2 things.
Yeah.
So help me break this up. What might I break 8 up into?
4 and 2.
4 and 2, yep. What might I break 45 up into? 9 and 5. And then a 200.
2 times 100.
Yeah, 2 times 100 for sure. So here's where I'm going to mess with in my square roots. I'm going to bring that one out, I'm going to bring that one out, and I'm going to bring that one out. Okay? So bring 4 out as a 2, negative 10 square roots of 2. Bring 9 out as a 3, that's 6 square roots of 5. Bring 100 out as a 10, that's 30 square roots of 2. So as I'm looking at these 3 things, are you noticing there's only 2 of them I can combine?
Yeah.
The negative 10 and 30.
Why?
Because they're not the same thing otherwise, right? Works a lot like terms. Okay. Now, one thing you can do to check your answer, you can slap this in your calculator and get a decimal, and slap this in your calculator and get a decimal, and it should be the same. Okay? Because from here to here, we didn't change value, we just simplified it, which means we changed how it looked. Jack?
Okay. Wait. Oh, never mind. I was gonna say that I didn't realize they could multiply them.
Yeah, so when I bring those out, that 2 comes out front and multiplies. 3 comes out front and multiplies. 10 comes out, multiplies. Now, one thing I want to make sure you understand is when we take the final, I'm going to be looking for this step. Because some people have calculators that'll just do it for them. Also, some people will open a tab and just Google it. And if the purpose of the test is for you to tell me that you understand it, do you think I have any concern about you touching buttons on a calculator?
Wait, we're allowed to use that?
No, you're not, I'm saying. But when people cheat, they don't actually know anything. The point of the test is to see what you know. Like, for example, are you allowed to look up what year the War of 1812 was on Google for social studies?
The year is 1812.
I know, okay. Maybe that's a bad example. But you know what I mean? If you're taking are you allowed to look up a map on Google when you're doing your geography test? No, like, it's right, we're testing your knowledge. It's not about giving you grade. It's about seeing what you know. So we're gonna if your calculator's one that's spitting out answers, I'll help you change the settings because you need to be able to show this intermediate step to show me that you understand what you're doing. Yes.
If we have a calculator that does that, can we use it to check our answer?
You could, but you could also just type that in and check your decimals to make sure they're the same.
Wait, can I test it?
Yeah, I don't think yours does. Okay. So moving on to multiplication. We're going to be 3rd page in your packet now. And I want to start with number 4, I believe. Nope, do not do number 4. Let's do number 3. We got 5 square roots of 10 times negative 7 square roots of 12. So notice here it's multiplication. Now, one thing, let's just do a quick little experiment. Square root of 4 times square root of 4. What do you guys think that equals?
Square root of 16.
Okay, so what is the square root of 16?
4.
So it's 2 times 2 equal to 4?
Yeah.
Yeah, so this is just justifying that you can multiply the things underneath. I'm just proving it to you, right? Like if you forget that that's true, just do a little experiment like that. So remember, nothing's magically attached. So this looks like 2 things, but is it actually 2 things? No, it's kind of actually like 4 things. Okay? So I'm going to multiply my 5 and negative 7, and I'm going to multiply my square root of 10 and square root of 12. That's the first thing I'm going to do. Nothing is magically attached, right? I can multiply in any order I want because of the commutative property of multiplication. Right? Everybody go with where I'm at so far?
I think I'm gonna write that.
Now, let's see how 120 is. How are you made 120? Is that show still on TV? How it's made? I used to love that show. Okay. So as I'm looking at this, what are you noticing as a perfect square factor?
2.
Yeah, there's just a 4, right? There's 2 2s. That's a factor of 4. 2 times 2 is 4. Okay? So as I break it up, I'm going to do square root of 4 times 30. And I know there's a 30 there 2 ways. I know how to divide by 4 real quick there. But also see how there's a 2, 3, 5? That's 30. That's all the factors. Okay? Okay. What does 4 say here? Cash me outside, baby. Negative 70 square roots of 30. There's no other perfect squares in 30.
Would you get the same answer if you split 12 into 6 and 2?
6 and 20? But neither one of those is perfect squares, so you can't mess with it, right? Good question, my man. Now let's jump down to number 7, I think. Nope, don't do 7. Let's jump down. Let's go number 10. No, I want an odd exponent, though. Let's go number 5. We're going backwards. Let's go 5. So remember,
Did we get x?
do you remember yesterday odd exponents?
Yes, you multiply them by half.
Yeah, well, 1/2 power is square root, right? So we cut them in half. Okay, so let's multiply here, and everybody go with 4 square roots of 36n cubed. Okay, I did 6n squared times 6n, which is 36n cubed. Now, 36, it's good to go, isn't it?
Yeah.
So we're going to leave that. But n cubed, I need to break that down to n squared times n, because I can't take the square root of an odd exponent. So 6 comes out, that becomes 24. N squared comes out as n. The other n has to stay home underneath. All right, so just remember, when you get that odd number of exponents, you get the closest to even, the even one below, and then one variable has to stay underneath. We good there?
Yep. How did
Yes,
we
we
get
are.
24?
Because square root of 36 is 6. 6 times 4 is 24.
I forgot.
Good question. Let's just have you try number 10 just for fun.
Yeah, just
Let's go. Hey, did everybody notice that one's multiply?
Yeah.
Okay, so I can't mess with 7x cubed square root of 6 yet. Okay, so when I multiply those two things, I get square root of 24x to the 6th.
yeah, that's
Okay? Okay, I'm going to break that 24 into a 4 times 6 times x to the 6th. I can get that 4 and x to the 6 out.
oh, x to the 6th. Wait, I thought we just
So we get 2x cubed square roots of 6 for a total of 9x cubed square roots of 6. Let's go. So you needed to identify that you had to multiply first.
But 6
Oh, I forgot it's.
but x to the 6th.
X to the 6, the square root of x to the 6 is x cubed.
Oh my god.
Because x cubed times x cubed is x to the 6th. You've got to remember that an exponent is different than a number, right? It's how many times you have that base factor.
That was not the one.
So I got negative 4 square roots of 2, and I'm going to multiply that by square root of 6 plus 3 square roots of 14. Now, you would order of operations do grouping first, right? But there's like nothing I can do with that. So if I can't do what's in the parentheses first, what's my other option here? What property? I can distribute, right? So I'm going to multiply both these things individually by negative 4 square roots of 2. So when I multiply negative 4 square roots of 2 by square root of 6, I get negative 4 square roots of 12.
Okay.
Then I'm going to multiply negative 4 square roots of 2 by 3 square roots of 14. That gives me negative 12 square roots of 28.
Okay, this makes sense.
So that's where I'm at after the distributive property.
Make more sense to me than yesterday.
Well, you have to know yesterday to do this.
I know, that's
So,
why I
sometimes when you practice something more, Sam, it gets better. Can you believe it? So here's where I'm at. This is just multiplying individual things, but now I got subtraction. So I'm going to be looking to simplify these now. What's a factor of 12 I want to mess with?
6 and 3 and 4. 3 and 4.
Yeah, not 6 and 2. That doesn't help us, right?
Yeah, I
What about factors of 28?
7.
4 and 7, right? Okay. Let's get these out. So I got negative 8 square roots of 3 minus 24 square roots of 7.
Is that it?
That's it. You can't do anything else with that, right? So that's it, man. DUN done. Stick a spoon in it. Really, you guys ever think about that? How do you spell done? D-O-N-E, which would make it a hard E, or done.
Who would make it done? Yeah.
So done really should be spelled D-U-N. No, yeah. D-O-N-E makes no sense. These are life's questions that I keep going unanswered for me.
These are good questions.
All right.